Good afternoon. Welcome to week 11 problem solving session. Today I'll be solving week 6 and week 7 assignment solutions. So let's get started. So the first question is x follows a gamma m lambda, y follows a gamma n lambda, and x and y it has been given that they are independent. Then what will be the distribution of x plus y? So if x follows gamma m lambda, then PDF of x can be written as fx will be equal to lambda to the power m my gamma lambda e to the power minus lambda x to the power m minus 1, where x can be greater than 0. This is the form of the PDF. Okay, so y also follows gamma n lambda. So then the PDF of y will be given as fy equal to lambda to the power n by gamma n to the power minus lambda y to the power n minus 1, where y is greater than 0. We have to find out the required PDF will be how much. It should be in some gamma format, so it should be something by gamma something, something by gamma something, e to the power minus something x to the power something minus 1. Okay, we have to just fill in the question marks. Now there are a couple of ways in which we can solve it, so we'll see both the ways. Alright, okay, so this is, let's say, option, or rather this will be first way. So here if we have fx and if we have fy, then we can use fx plus y equal to minus infinity to infinity fx of x and fy of z minus x. So this will be x plus y z. Okay, so then this into dx. Alright, so then what we have to do, since fx and fy into dx, this thing, so here we'll just substitute. So this will be lambda to the power m x to the power m minus 1 e to the power minus lambda x by gamma m into, this will be lambda to the power m by gamma n z minus x whole to the power whole to the power n minus 1 into e to the power minus lambda z minus x. Now this entire thing we have to integrate from 0 to infinity, that is the range of x into dx. Alright, so if we take the constant terms out, lambda m plus n by gamma m gamma n 0 to infinity x to the power m minus 1 z minus x to the power n minus 1 and e to the power minus lambda z dx. Okay, so this thing we can write it as lambda to the power m plus n by gamma m gamma n e to the power minus lambda z 0 to infinity x to the power m minus 1 and z minus x whole to the power n minus 1 dx. Okay, now let us consider u equal to x by z. Okay, so du will be dx by z, alright, or dx will be z du. Alright, now we'll just substitute in place of x. We are going to write it in terms of u and z. Okay, so what we are going to do is lambda m plus n by gamma m gamma n e to the power minus lambda z. So x can go from 0 to infinity, so u can also take values from 0 to infinity. So it will be 0 to infinity, x will write it as uz to the power m minus 1 and this thing we'll write as z minus x will be uz whole to the power n minus 1 du. Alright, so this one we can write as this will be equal to lambda to the power m plus n by gamma m gamma n e to the power minus lambda z 0 to infinity u to the power n minus 1 here 1 minus u to the power n minus 1 into z to the power m minus 1 plus n minus 1 dz. Alright, so this will be lambda gamma gamma m gamma n e to the power minus lambda z z to the power m plus n minus 2 0 to infinity u to the power m minus 1 1 minus u to the power n minus 1 du. Now this one essentially is a beta function. So this will come down to So this will be lambda to the power m plus n by gamma m gamma n e to the power minus lambda z to the power m plus n minus 2 okay, here I made a mistake. So instead of dx we should write z du. So another z is going to come over here, so it will be z du. So this will be n minus z to the power m minus 1 plus n minus 1 plus 1. So we would here have z to the power m plus n minus 1. And this is essentially a beta mn. Now a form of a beta function is beta mn is gamma m by gamma n by gamma m plus n. So this one would be lambda to the power m plus n by gamma m gamma n e to the power minus lambda z to the power m plus n minus 1 into gamma m gamma n by gamma m plus n. So if we cancel these and make the calculations, then we would have lambda to the power m plus n by gamma m plus n e to the power minus lambda z to the power m plus n minus 1. So which is the PDF of a gamma m plus n lambda. Alright, so the answer would be gamma m plus gamma n. If they are independent, then this would be gamma m plus n into lambda, the first one. Alright, this was one method, one way out to solve this question. There is another way by which you can also solve, which is called the moment generating function way, which I am going to demonstrate. Okay, so this will be my way out 2. Okay, so this is, or I could say, second method. This one was the first method. Alright, now I am going to show you how you can solve such problems using moments as well. Okay, now MGF of x is expectation of e to the power tx. So this will be integration 0 to infinity e to the power tx into lambda to the power m by gamma m e to the power minus lambda x to the power m minus 1. So this one would be 0 to infinity lambda to the power m by gamma m e to the power minus lambda x plus tx x to the power m minus 1. So this would be 0 to infinity lambda to the power m by gamma m e to the power minus lambda minus t x into x to the power m minus 1. So this one we can write down as So this can be written as this part we can take out, lambda to the power m by gamma m 0 to alpha e to the power minus lambda minus tx. This will be x to the power m minus 1. Now this entire thing is equal to a gamma m by lambda minus t to the power m. Alright, so gamma m will cancel, and we would have 1 by lambda minus t by lambda whole to the power m. So this would be 1 by 1 minus t by lambda whole to the power n. Okay, so this is the MGF of a gamma distribution. So similarly, if y also follows gamma n, then MGF of y would be 1 by 1 minus t by lambda to the power n. Okay, because it was following n lambda. This is 1 by 1 minus t by lambda whole to the power m. My t is 1 by 1 minus t by lambda whole to the power n. Now since x and y are independent random variables, we have the following result. We have m x plus y t, the moment generating functions. If it is a plus thing, then this can be written as mxt into my of t. Okay, this is an important result that we should keep in our mind. So then using this, we have mx plus yt equals to 1 by 1 minus t by lambda to the power m into 1 by 1 minus t by lambda whole to the power n. So this is can be written as 1 minus t by lambda whole to the power m plus n. Okay, which is nothing but a MGFs are unique. So MGF of this is the MGF of a gamma m plus n lambda. Therefore x plus y would follow this thing, gamma m plus lambda. So here we would have lambda to the power m plus n by gamma m plus n. Here we would have lambda, and here we would have m plus n. Alright, so if this is clear, we'll move on to the next one. Okay, so here also let x and y be continuous random variables with where the joint probability function has been given, and we have to find out the value of k. So we know that double x integral fxy dx dy over range of x and y will have to be equal to 1. So we'll apply the same thing. Since the ranges are independent, there are no restrictions on x and y. It can take freely from 0 to 1. K 2x plus 3y dx dy. So we can write this as 0 to 1 k 2x square by 2 plus 3xy from 0 to 1 dy. This would be 2 to cancel out, 0 to 1 kx square plus 3 by 2 x square y, sorry, so this would be so this would be, we would substitute 1 in place of x, so we would have k 1 plus 3 y dy. Okay, then this one we can write as one second. So we can write this as 0 to 1 k 1 plus 3y dy. So this would be 0 to 1 k into y plus 3y square by 2 0 to 1. Okay, so here we'll have 1 plus 3 by 2, so this is k into 5 by 2. Now k into 5 by 2 should be equal to 1, which implies k equal to 2 by 5, and that is the answer. Alright, next we'll move on to the next one. Okay, suppose x and y be two continuous random variables with the probability density function such as this, then what is the marginal PDF of y? So marginal of y will be integration of fxy over dy. Now here what will it be? It will be 2x into dy. Now we have to find out where does y range from. So the range of y is from 0 to x, so it will be x. So here we would have 2 x square by 2 from 0 to x. Sorry, we are integrating over y, right? So it will be 2x will come here, 0 to x dy. So we would have 2x y 0 to x, it will be 2x square. Okay, and x will take value from 0 less than x less than 1. Then the marginal of fx is of PDF is, so we can write fx is equal to 2x square, 0 less than x less than 1 and 0 otherwise. Okay, this is the answer. Alright, so now we'll move on to the next one. So here they are asking if x and y be IID exponential lambda, let z equal to maximum of x and y, then the distribution of z and x plus half y is the same, state true or false. So first we'll find out the distribution of z. Okay, so probability z less than equal to small z equal to probability max of x and y less than equal to small z. So here, if the maximum is less than z, which implies probability x is less than z, y is also less than z. And since x and y are independent, we can write it as x less than equal to z, y less than equal to z. And since they are, we can write it because since x and y are independent. Okay, so this we can write as 1 minus e to the power minus lambda z. This is the CDF of a exponential distribution with mean 1 by lambda, and this one is also 1 minus e to the power minus lambda z. So it is 1 minus e to the power minus z whole square. This is the CDF. So then PDF will be, so CDF is what? CDF is 1 minus e to the power minus lambda z whole square. So PDF will be ddz of CDF. So it will be 2 1 minus e to the power minus lambda z into minus e to the power minus lambda z into minus lambda, that is equal to 2 1 minus e to the power minus lambda z into lambda e to the power minus lambda z. So it will be 2 lambda e to the power minus lambda z 1 minus e to the power minus lambda z. Okay, this is the distribution of max. Now we have to find out the distribution of z and x plus half y equal to same or not. Okay, so now we have a new variable x plus half y. All right, let us say that let v equal to half y. All right, so now the Jacobian, or we'll ask del new by del old, this will be del u del x del v del x del u del y del v del y. So this is the 1 by Jacobian. Okay, so this is del u del x is 1, del v del x is 0, del u del y is half, and del v del y is also half. Then we'll take determinant. So this one is determinant. So we have half. All right, therefore absolute, this is absolute value of Jacobian. This is 2. All right, so once we have worked this out, then f of uv is equal to f of xy into Jacobian of j. Okay, so then we have, this is 2, and fxy was how much? It was lambda e to the power minus lambda x into lambda e to the power minus lambda y. So in place of x and y, we are going to write u and v. So essentially it was, so I'll write it in the side. Okay, so here we had fxy was lambda into e to the power minus lambda x, lambda e to the power minus lambda y. So it was lambda square e to the power minus x plus y, minus lambda x plus y. So this, instead of x plus y, u is x plus half, v is half y, v is also half y. So here we can write it as lambda square e to the power minus lambda. This one we can write it as u plus v, and then this thing we can write it as Jacobian of j is 2. So we have 2 lambda square e to the power minus lambda u plus v. Now f of v, want the distribution of u. So f of u would be integration of f uv dv. So here we would have 0 to infinity 2 lambda square e to the power minus lambda u plus v into dv. Alright. So this will be 2 lambda square e to the power minus lambda u, 0 to infinity e to the power minus lambda v dv. Alright. Now that is equal to 2 lambda square e to the power minus lambda u e to the power minus lambda v by minus lambda from 0 to infinity. So this will be 2 lambda square e to the power minus lambda u this will be 0 minus of minus 1 by lambda. So ultimately we have 2 lambda e to the power minus lambda u as the PDF of x plus half u. But it shouldn't be there, it should come as 1. All right. Okay, so then the PDFs are not matching because, but we should have some 1 minus e to the power lambda z. Half x plus half y, x goes from 0 to infinity, y also goes from 0 to infinity, so x plus half y will also take values from 0 to infinity. This is okay. V is half y and Jacobian is 2. This is fine. this is 2 lambda square to the power minus lambda u plus v is also fine. The integration with respect to dv into minus lambda v there seems to be some problem here. Some 2 should come over here. 2 lambda u. Okay, maybe there's some problem with the solution. So the answer will be false in this case. I don't know why they have given true. I don't think that the question is correct. Alright, let us move on to the next one without wasting time on this one, because I think this is not correct. So let x and y be a discrete random variable vector with support this, and the joint medium is given by this. So x and y, x can take values from 1 and 2, and y can take values from 0, 1 and 2. Okay, so 1 0 combination, this is half, 1/4. 2 0 is also 1/4. x1 y1 is 1/4, and 1 0 2 0 1 1 1 2. All right, so support is only given that way. Fine. All right, it could be 1 0 2 0 1 1 1 2. So 1 0, the probability is 1/4. 2 0, the probability is 1/4. 1 1 is also probability 1/4, and this is also 1/4. Total is 1. Alright, so probability x equal to 1 given y equal to 0 is probability x equal to 1 y and y equal to 0 by probability y equal to 0. Okay, now this one, x equal to 1 y equal to 0, this can be written as x equal to 1 y equal to 0, this probability is 1/4, by probability y equal to 0 is probability x equal to 1 y equal to 0 plus probability x equal to 2 y equal to 0. This is by theorem of total probability. Alright, so here we have 1/4 by 1/4 plus 1/4, that is 1/4 by half, which is equal to half. So answer is 0.5. Alright, so let's move on to the next one. Okay, same thing they are saying, x equal to 2 given y equal to 0. This is equal to probability x equal to 2 and y equal to 0 by probability x equal to 2 y equal to 0 plus probability x equal to 1 y equal to 0. So this would be 1/4 by 1/4 plus 1/4, again half. So answer would be 0.5. Alright, now let us move on to the next one. The joint probability density of a random variable is given by 2x e to the power minus x 2 plus y. The probability density function of x is given by how much? So PDF of x equal to integration fxy dy. So it will be 0 to infinity 2x e to the power minus 2x into e to the power minus xy dy. Now you see we have an xy term over here. So the best way is to remove this xy and substitute it with another random variable u, make transformations and then get the PDF of x. Alright, so xy, if we do u, then also there is a problem. Then here we have x again we have to substitute by u by, okay, let's see. So x dy equal to du. Alright, so dy is du by u and x is u by y. This will become a little problematic if we solve it that way. I think it's better to write the joint PDF and get it. Alright, let's see what happens. Xy equal to u, x dy equal to du. So x dy we can write it as du, 0 to infinity 2 du e to the power minus u e to the power minus 2x we can write as 2u by y. Then again this term is involved and this will keep on going. U by y, you take something, then this one, these will keep on changing. So the best way is to make a transformation. So we'll try that transformation method now. Alright, so in order to remove this xy term, so this would be 2x e to the power minus 2x into e to the power minus xy. So let u equal to xy and v equal to x. So then 1 by Jacobian will be del u del x, del u del y, del v del x, del v del y, determinant of that. So here we would have y x 1 0. So it is y. Alright. So the Jacobian will be 1 by y. Sorry, this is y into 0 minus x. So this determinant is minus x. So mod of Jacobian will be one by x. Alright. So then f u v we'll write as 2, x we'll write as v, e to the power minus 2v, e to the power minus u into 1 by x we'll write it as 1 by v. This v will cancel. So this is 2 e to the power minus 2u e to the power minus 2v, sorry, here 2v e to the power minus u. Then we want the distribution of x, that is we want the distribution of v. Therefore if v equal to integration 0 to infinity 2 e to the power minus 2v e to the power minus u du. Alright, so this one it will be 2 e to the power minus 2v 0 to infinity e to the power minus u du. This is 2 e to the power minus 2v to the power minus u minus 0 to infinity. That will be 2 e to the power minus 2v 0 minus 1, 0 minus minus 1, it is 1. So we'll have, okay, so fv is 2 e to the power minus 2v, or in other words fx equal to 2 e to the power minus 2x. That is the answer. Alright, so now we'll move on to the next one. So here let x and y be jointly continuous, let x and y be jointly continuous random variables with the following joint PDF. Then what is the probability x is greater than y? Alright, so in order to solve this, probability x greater than y will be, let us fix a certain y. Okay, so then x has to be, let us fix y, then x has to be greater than y. So x can take value from y to infinity, okay, and y can take values from 0 to infinity. So this will be my order of integration. Alright, so here we would have 6e minus 2x plus 3y. So this would be 0 to infinity, y to infinity, 6 will take out, e to the power minus 2x into e to the power minus 3y dy dx. So 6 e to the power minus 2x we can take out, so we will have 0 to infinity 6 e to the power minus 2x, y to infinity e to the power minus 3y dy then dx. Alright, so this thing we can write it as 0 to infinity 6 e to the power minus 2x, y to infinity e to the power minus 3y dy, and this one entire thing dx. So what we had is 0 to infinity 6 e to the power minus 2x, e to the power minus 3y by minus 3, y to infinity. So this we would have 0 to infinity 6 e to the power minus 2x. This would be 0 minus of e to the power minus 3y by minus 3. So we would have ultimately 0 to infinity 6 e to the power minus 2x by 3 e to the power minus 3y to dx. Alright. Alright, so here we would have, which is equal to extremely sorry, here I said something and I wrote something else. No, I will redo this. Alright, excuse me. Okay, so probability x greater than y. So let us fix y first, then x can take values from y to infinity, and then y can go from 0 to infinity. Alright, here we would have our fxy. So this would be our range of integration. So here we have 0 to infinity y to infinity 6e minus 2x plus 3y dx dy. So here we would have 0 to infinity 6 e to the power minus 3y will take out, then we will have y to infinity e to the power minus 2x dx, then we have dy. So this will be 0 to infinity 6 e to the power minus 3y e to the power minus 2x by minus 2. This will be y to infinity. Alright, so this we can write it as 0 to infinity 6 e to the power minus 3y then minus 2x by minus 2 is y to infinity. This is y to infinity. Excuse me. All right. So here this will be 0 to infinity 6e to the power minus 3y, 0 minus of e to the power minus 2y by minus 2. Okay, so this will be 0 to infinity 3 e to the power minus 3y into e to the power minus 2y. So it will be 3 e to the power minus 5y dy. Alright, so here we will have 3 e to the power minus 5y by minus 5 in 0 to infinity. So that would be 3 e to the power minus 5y by minus 5 would be 0 to infinity. It will be 3, 0 minus of minus 1 by 5. So we will have 3 by 5, and that is the answer. Alright, so let us move on to the next one. Now they are asking, let x and y be jointly continuous, are x and y independent, true or false? If xy is this one, 6e minus 2x plus 3y. If x is 6e minus 2x plus 3y integration over dy, this will come as 2e to the power minus 2x. You can check it because this 3 by 3 will come 2, and in the previous step only we did this. Okay, from 0 to infinity, and fy will similarly come 3e to the power minus 3y, since fx into fy equal to fxy, therefore independent. So the answer is true. Alright, now we'll move on to the next one. So here they are saying x follows binomial 2 1 by 3. So x can take values 0, 1 and 2, and y follows binomial 3 half. Y can be 0, 1, 2, 3. Okay, so probability x equal to y is probability x equal to 0, y equal to 0 plus probability x equal to 1, y equal to 1 plus probability x equal to 2, y equal to 2. Now this one equals probability x equal to 0 into probability y equal to 0, since they are independent, plus probability x equal to 1, probability y equal to 1 plus probability x equal to 2 into probability y equal to 2. Now we just have to substitute 2c0, this is 1/3, half to the power 0, 2/3 to the power 2 into 3c0, this is what, half to the power 0, half to the power 3 plus similarly 2c1 1 by 3 2 by 3 whole square into 3c1 half to the power cube plus 2c2 1 by 3 square 2 by 3 0 into 3c2 half cube. Okay, so this would be 2c0 is 1 into 2 by 3 square plus 3c0 is 1. Okay, 2 by 3 square, this is equal to 2 by 3 square into half cube plus 2 by 3 into 2 by 3 square half cube plus into 3 half cube plus 2c2 is 1 1 by 3 square is 1 by 3 square 3c2 is 3 half cube. Okay, so this one is, so we would have 2 square by 3 square 2 cube plus 2 cube by 3 square into 2 cube plus 3 into 3 square 2 cube. So ultimately we would have 4 by 3 square 2 cube plus 8 by 3 square 2 cube plus 3 by 3 square 2 cube. So this is by 72, 14, 15 by 72 is the answer. Oh no, they are saying 19 by 72. It must be some calculation mistake. 2c0 is 1. This is 4 into 3c0 is 0. This is 4 plus this is 2c1, so 2 into 1 by 3 into 2 by 3 to the power 1, sorry. So here we would have 2 by 3 to the power 1. So ultimately that would be 6 into 2 into 2 4 4 into 3, that is 12. This will be 12 by this thing. So finally we would have here, instead of 8 we would have 12 So the correct answer is 19 by 72. Okay, so let us move on to the next one. Okay, so suppose we toss a penny 3 times. X1 denotes the number of heads we get in 3 tosses. Suppose we toss a second penny 2 times, and X2 denotes the number of heads we get in those 2 tosses. So if y equal to x1 plus x2, then y denotes the number of heads in 5 tosses. Note that x1 and x2 are independent, and therefore y is the sum of independent random variables. What is the mean y? The sum of 2 random variables. And what is the variance of y? So y equal to x1 plus x2. Expectation of y will be expectation of x1 plus expectation of x2. Now x1 follows binomial 3, number of heads, probability if nothing is mentioned, it's half. x2 follows binomial 2, half. So expectation of x1 is 3 by 2, expectation of x2 is 1. So this will be 3 by 2 plus 1, that is 5 by 2, which is equal to 2.5. Now it is given that they are independent random variables x1 and x2, because the coins are separate, and the outcome of x1 in the first coin will not depend on what the outcome is for the second one. So for that reason, variance of y, we can write it as variance of x1 plus variance of x2. I'll write it in a separate page. Alright, so here we have variance of y equal to variance of x1 plus variance of x2. So this will be x follows binomial 2, one by 3, and y follows binomial, x follows binomial x1 follows binomial 3 half, and y follows 2 half. So x plus y will follow 5 half. Yes. So variance of x1 and variance of x2, we can add it since they are independent. The actual covariance is the actual term is this thing. So this part is 0 since independent. Alright, so we would have variance of x1 plus variance of x2. Variance of x1 is 3 into half into 1 minus half plus 2 into half into 1 minus half. So here we have 5 by 4, which is 1.25. Okay, so this is the answer, option D. Alright, here So this one I think I solved last time, the last week itself. Here the catch is, if I have n babies, so here the thing is, the trials are not independent. Alright, so variance of x will be, so the formulation is that xi equal to 1 if ith person identifies correctly, and probability is 1 by capital N. Alright, so x is number of correct answer, that is summation I equal to 1 to n. Alright, so expectation of x will be summation I equal to 1 to n, 1 by n, that is 1, no doubt about it. Now variance of x would be variance of summation I equal to 1 to n, xi would be summation of I equal to 1 to n variance of xi plus double summation I not equal to j to covariance xi xj. Now here the probability is going to change. Covariance xi xj will be expectation of xi xj minus expectation of xi into expectation of xj. Okay, and xi xj will be 1 if ith person identifies correctly and jth person also identifies correctly and 0 otherwise. So probability xi xj equal to 1 is ith person identifies 1 by n, and the jth person out of the remaining n minus 1, the jth person is also able to do it, identify correctly. This is the only catch. So expectation of xi xj is 1 by n into 1 by n minus 1. So we just have to substitute these values to get the covariance terms. So here if I substitute, I would have 1 by n into n minus 1 minus 1 by n square. So it would be n into n minus 1 this would be n minus n minus 1, so it would be 1 by n into n minus 1 again, and then we'll substitute this covariance terms in the variance terms. So variance of xi will be 1 into 1 by n minus 1 by n square, so it will be n square n minus 1. So we just have to substitute these individual values over here, and then finally we would end up at variance of x is also equal to 1. The detailed solution I did last week, you can go back and check. Alright. Now here is a question that says that if x and y are IID random variables, is it necessarily true that expectation of x by x plus y equal to expectation of x by expectation of x plus y? Now this is the so this thing, it does not hold always. Okay, so if you have something like this, expectation of xy, and x and y are independent, then we have expectation of xy equal to expectation of x into expectation of y. But the thing is, this one and this one, they are they have to be independent. There cannot be any dependence between these two variables. For example, if I have x by y, then also I can write this as expectation of x into expectation of 1 by y. So here also these two are independent, but here x and x plus y, they are not independent. Okay, so this will not hold true. And another example to support this is, let's say x follows a Bernoulli with probability 1/2. Y also follows a Bernoulli half. So x plus y will follow a binomial 2/2. Okay, independently. Now let us say that x can take values 0, 1, y can also take values 0, 1. Alright, so here 0 is half, half, this is also half, this is also half, 1/4, 1/4, 1/4, 1/4. Alright, now this is an independent thing. Now x by x plus y, this only exists when x plus y is not equal to 0. Okay, so this is one thing that we should keep in our mind, that this will only exist when x plus y equal to 0. Sorry, x plus y is not equal to 0. So when at 0 this is not defined, let us say wherever it is defined, so then let us have so x plus y, this will exist only when x plus y equal to 1 or x plus y equal to 2. Okay, so then when this is true, when x plus y is 1, how will it be? X equal to 0, y equal to 1, or y equal to 0, x equal to 1. Alright, so then wherever this is existing, so expectation of x by x plus y, so this probability is how much? This probability is 1/4, this probability is also 1/4, and this probability is also 1/4. So together x by x plus y, it can take non-zero probability, that is 3/4. So the total probability that should add up to 1, that thing is only not holding true here. Alright, so it is not necessarily true that this one is equal to expectation of x by expectation of x by y. Alright, even if we do this sort of calculation, expectation of x into expectation of x plus y, this will not hold true. So this is not necessarily true, only because this numerator and denominator, they are not completely independent. If the numerator and denominator were completely independent, then we could have said that, but no, since denominator also contains a numerator term, we cannot say that this holds true always. Alright, so here we have xy, we have to find out covariance of xy. Equal to expectation of xy minus expectation of x into expectation of y. Expectation of xy will be xy into 2. X can run from 0 to y can be from 0 to 1. Okay, so this will be 2y 0 to y x dx dy 0 to 1, that is 0 to 1 2y y square by 2 dy. This is 0 to, okay, I have written it directly. So this will be 0 to 1 y cube dy. This is y to the power 4 by 4, 0 to 1, that is equal to 1 by 4. Okay, and expectation of x is how much? It is x into 2xy dy from 0 to x. Sorry, we have to write down the expectation of x into expectation of y. So first we have to find out expectation of x. So let us find out the PDF of x first. Fx equal to integration of fxy dy. Now y can range from x to 1. So this will be x to 1 to dy. So it will be 2 into 1 minus x. Alright, and expectation of x would be 2x into 1 minus x dx. X can take value from 0 to 1. So it will be 2x minus 2x square dx 0 to 1. It will be x square minus 2x square by 3 0 to 1. So this will be 1 minus 2 by 3, that is 1 by 3. Okay, expectation of x is 1 by 3. And similarly, if y is fxy dx, x can take value from 0 to y. Okay, and then x can, so this would be 0 to y 2 dx. So it will be 2y, and then expectation of y will be 2y into y 0 to 1 dx. So it will be 2 y cube by 3 0 to 1, that is 2/3. So therefore covariance xy will be 1/4 minus 1/3 into 2/3. So it will be 1/4 minus 2 by 9. So this will be 1/4 9 minus 8, that is 1 by 36. This is the answer. Alright. Okay. So let x1 and x2 be discrete random variables, have then the expected value of x and variance covariance matrix of x is this one. Okay. So x is x1 and x2. So expectation of x would be expectation of x1 and expectation of x2. So this would be expectation of x1 is how much? So we have to add up x1 and x2. So x equal to 1, the probability, so we'll write it here, x1, x2, it can take values 1 and 2, it can take -1, -0, 1. So x1 equal to 1, the probability is 1 6 plus 2 6, that is half. x1 equal to 2, that is also 3 by 6, that is half. Okay, this is x1 marginal. And this one, this is x2 marginal. So x2 is -1 is 2 by 6, that is 1 3. This is also 1 by half, and this is 1/6. Alright, it's adding up to 1. Alright, so expectation of x1 is 1 into half plus 2 into half. Expectation of x2 is -1 into 1 by 3 plus 0 into half plus 1 into 1 by 6. So this is half plus 1, that is 3 by 2, and this is -1 by 3 plus 1 by 6, that is -1 by 6. Okay, so this is the expectation vector. Now we have to find out what is the variance covariance matrix. Here also we have to keep this table in mind in order to calculate the variance. So variance of x1 is how much? Expectation of x1 square minus expectation of x1 whole square. Okay, so expectation of x1 square is how much? This is 1 square into half plus 2 square into half minus expectation of x1 was 3 by 2. 3 by 2 whole square. So we have half plus 4 by 2 minus 9 by 4. So what do we have? 5 by 2 minus 9 by 4, that is 4, 10, 1 by 4. Alright, so this so this is 1 by 4. Variance of x1 is 1 by 4, and similarly variance of x2 is how much? Expectation of x2 square minus expectation of x2, that things whole square. So here expectation of x2 square is -1 square into 1/3 plus 0 square into half plus 1 square into 1 by 6 minus expectation x2 was how much? 1 by 6. So this will be minus 1 by 6 whole square. So here we have 1/3 plus 0 plus 1/6 minus 1/6 whole square. Okay, so here we have 36, 12 plus 6 minus 1. So this is 17 by 36. So variances we have, okay, so So the first variance will be 1 by 4, and this diagonal is this one, 17 by 36. Now we have to find out the covariance. Now covariance, just see here, the covariance terms do not match, so this is automatically excluded from our choice. Alright, covariance terms has to match, because covariance xy is the same as covariance yx. Now how do I actually find the covariance term? So covariance xy is how much? This is expectation of xy minus expectation of x into expectation of y. Alright, so expectation of x, we know it is something, it is 3 by 2 and minus 1 by 6. So this is 3 by 2, this is minus 1 by 6. Now we have to find out this one. So expectation of xy, we have to remember this table. Expectation of x1, x2. I should write x1, x2, x1 and x2. Okay, x1 is this side, x2 is this side. It can take value 1 and 2. It can take value minus 1, 0 and 1. Okay, so it has been given that, no, nothing has been given. So this is these probabilities they have given 1 by 6, 2 by 6, 1 by 6, 2 by 6, and then what, 1 by 6, 2 by 6, 0, and then this is 1 by 6, 1 by 6 and 1 by 6. So expectation of x1, x2, this is what? This is expectation of x1, x2. This is minus 1 into 1 into 1 by 6 plus 0 into 1 into 2 by 6 plus 1 into 1 into 0. Okay, plus minus 1 into 2 into 1 by 6 plus 0 into 2 into 1 by 6 plus 1 into 2 into 1 by 6. So this is how much is it coming to? See, this is minus 1 by 6 plus 0 minus 2 by 6 plus 0 plus 2 by 6. So this will be minus 1 by 6. So expectation of x1, x2 is minus 1 by 6. So if we have to, so then the covariance becomes covariance x1, x2. This is minus 1 by 6 minus of 3 by 2 into minus 1 by 6. So this comes to 1/4 minus 1/6. 3 minus 2, that is 1 by 12. So the variance covariance matrix is written by sigma is nothing but 1/4. Variances, we have to note, they are always the diagonal elements and they are always positive. So variance is 17 by 36 and off diagonal elements are 1 by 12. Alright, so then this is the answer. Sorry, not this. 3 by 2 minus 1 by 6. Yes, C is the answer. Alright. Moving on. Okay, so if x and y are independent random variables with variances 8 and 5, then variance of 3x plus 4y is how much? Variance of 3x plus 4y is 9 variance of x plus 16 variance of y plus 2 into 3 into 4 covariance of xy. So this will be 9 variance of x plus 16 variance of y plus 6 into 4 24 covariance xy. Now since x and y are independent, therefore covariance term will be 0, so we would end up with 9 variance of x plus 16 variance of y. So it will be 9 into 8 plus 16 into 5, so that is 72 plus 80 will be 152 is the answer. Alright, we'll move on to the next one. Okay, so similarly, if x and y are independent, we have to find covariance between x plus y and x minus y. Okay, so similarly we'll write it in a similar fashion. Covariance of x plus y and x minus y, this would be covariance of xx minus covariance of xy plus covariance of yx plus covariance of minus covariance of yy. So this is essentially variance of x minus covariance of xy plus covariance of xy minus variance of y. This one is cancelling. So we have variance of x minus variance of y. Alright. It doesn't matter if it is independent or not, because here it is cancelling each other out. Alright, next we'll move on to the next one. So here it says if the joint PDF is given by this, then find expectation of xy. So expectation of xy is 0 to infinity, 0 to infinity, xy e to the power minus x plus y dx dy. So this one is 0 to infinity, integration of, since this can be separated out, we can write it as x e to the power, we can write it as y e to the power minus y into integration 0 to infinity x e to the power minus x. dx and dy. Alright, so we could solve this part by parts, or if we are judicious enough, this is expectation of some z where z follows exponential 1. Okay, so then the mean of the expectation z where z follows exponential 1, the mean is also 1, so this entire thing will be 1. So we would have this as 0 to infinity y to the power minus y into 1 dy, and this is also expectation of some p where p follows exponential 1, so this will also be 1. Alright, so that is the answer. Okay, now we'll move on to the next one. So if variance of x equal to variance of y equal to sigma square and covariance of xy equal to sigma square by 2, then find the correlation between 2x plus 3 and 2y minus 3. Alright, so correlation between 2x plus 3 and 2y minus 3 is equal to covariance. This is relation, okay, correlation R. This is equal to covariance between 2x plus 3, 2y minus 3 by root over variance of 2x plus 3 into root over variance of 2y minus 3. Now these things we have to find out. So covariance 2x plus 3 2y minus 3 equal to 4 covariance of xy, which is equal to 4 sigma square by 2, which is equal to 2 sigma square. Alright, and here variance of 2x plus 3 is 4 variance of x, and variance of 2y minus 3 is also 4 variance of y. Now variance of x has been given as sigma square, so this is also 4 sigma square, this is also 4 sigma square. Therefore correlation 2x plus 3 to y minus 3, this is equal to 2 sigma square by root over 4 sigma square root over 4 sigma square is equal to 2 sigma square 2 sigma 2 sigma. So this will be equal to half. That is the answer. Alright, so here we have if x and y are discrete random variables, okay, find variance of 2x minus 3y. So variance of 2x minus 3y is 4 variance of x plus 9 variance of y minus 2 into 2 into 3 covariance of xy. So this will be 4 variance of x plus 9 variance of y minus 12 covariance xy. So this is 4 sigma square by 2. No, this is 4 sigma square. This is 4 sigma square plus 9 sigma square minus 12 sigma square by 2. So we have 13 sigma square minus 6 sigma square, which is 7 sigma square. That is the answer. Alright. So now I'll move on to the next one. So let's say there are 100 men on a plane. Let xi be the weight in pounds of the ith man on the plane. Xi is our IID. So they have given 100 men on the plane. Suppose that xi is our IID with expectation of xi equal to mu equal to 1.0 and standard deviation xi equal to sigma equal to 30. And probability that total weight exceeds. So total weight equal to summation xi. Alright. So probability summation xi is greater than 18,000. This is probability summation xi minus expectation of xi is 170. So we are considering 100. So 17000 by where SD of xi is 30. So variance of summation xi is summation variance of xi. So this will be summation of into 100, 30 square into 100. This will be 90000. Okay, so SD of summation xi will be 300. So by 300 is greater than 18000 minus 17000 by 300. Okay, so it will be 10 by 3. So we would have here equal to probability summation xi minus 17000 by 300 greater than 1000 by 300. Sorry, 1000 by 300 to probability by CLT. It will go to probability z greater than 10 by 3. That is probability z greater than 3.33. That is equal to 1 minus probability z less than equal to 3.33. This will be very small. So P norm 3.33 is how much? 0.99. So 1 minus this thing will be 3.33 0.00434. So this is 0.00434. That is 4.3 into 10 to the power minus 4. Something similar has been reported. 4.3 into 10 to the power minus 4. Yes. So here we have another similar problem where we have been asked to use CLT. So CLT or central limit theorem states that x bar, so central limit theorem states that x bar minus mu by sigma by root n if n is sufficiently large, it converges in distribution to a standard normal distribution, provided n is very 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 large. Okay, so now here we have been asked to find out that the probability x bar is exceeding 1000 hours, sorry 1050 hours. So what we have to do is, this will be probability z greater than 1050 minus 1000 here by 250 by root 10. Now provided n is very large, in this problem n is not specified, so we can do these calculations taking n very large, 1000, 10,000 and as we wish, but I don't think the answer will match in that sense. I mean, so the general procedure to do this is, we will have to subtract the mean and divide by sigma by root 10, the total number of bulbs that we are testing, and if n is sufficiently large, we could compute this value and get it and search for the ID by first decimal and second decimal in this normal table. Whatever value we get, we do a 1 minus of that thing to end up at a to arrive at a solution. Alright, so in this problem n is not given, so we are unable to do this. We could assume n and go ahead, but that would not guarantee the required results. So yeah, that's all. This is how you should solve a CLT problem. So thank you so much for joining today. I hope to see you in the next session, where I will be covering more on assignment 8 questions, and also I'll try to cover assignment 9 and 10. Okay, thank you.